Hello friends, welcome to our new video. Today I am going to introduce one new module and its name is Shift Register module. As you see, it's a simple module with 4 integrated circuits and 32 LEDs. You can see at the top of the module. So the bottom part is its input side and the top part is its output side. So we can take outputs from the top side by connecting burge strips. Similarly, by connecting burge strips in the bottom, we can give inputs to this module. So most of you may know what is shift register module. Actually, the main use of this module is this is a picture of this module. So you can see the output side, and this is another picture where you can see input side. So the main advantage of this module is, if I am saying an example, so as you know, in an Arduino you can see 13 digital input or output pins. Similarly I think around 5 analog input or output is also available. So suppose you are in a situation that you need a lot of output pins, means 30, 40 or 50. If you want 30 or 40 output pins for controlling some systems like LED matrix, LED cube or servos, what you will do? So in such occasions, there will not be ample output pins in the Arduino board. So we have to go for some other options where we can get more outputs. So this module will simplify that effort. Means main advantage of this board is, from your Arduino board you can connect using only 3 digital input or output pins of Arduino. We can get 32 digital outputs. Means we should give an input through 3 digital input or output of Arduino, and in the output of the shift register module you will get 32 digital outputs. So don't be confused, we will get only digital outputs, 32 digital outputs. That we cannot use it as input. So now I am going to wire the circuit. So I am connecting the 12th digital input or output pin of Arduino to the left extreme input of shift register module. Similarly, I am going to connect the second input pin of shift register module to the 11th digital input or output pin of Arduino. And next I am going to connect 10th digital input or output pin of Arduino to the third input of shift register module. So by this wiring of the input signals are over. Next we have to power the shift register module. Powering will be done from the Arduino board itself. For that we have to take 2 connections from the VCC, 5 volt and ground pins of Arduino to shift register module. we are connecting the ground. And further we will connect the 5 volt. So the entire circuit is over. Earlier I showed you the picture of the circuit diagram, so you can easily sketch that circuit diagram in some minutes ago in the same video. Now I am going to power the Arduino board. I am powering the Arduino board from the computer itself through that black cable, as you see. Next is the programming part of this Arduino. So the hardware is over. Further it solely depends on the program. So I shall show you how the program will be in the as two sections in the screen. So there are 32 LEDs in the top side of the shift register module. 32 LEDs stand for the 32 LEDs are for understanding what is the current status of that respective pin. Means if the LED is on, the output will be high, or if the LED is off, the output will be low. Now in the right side you can see the program. Choose your serial port and choose your board. Here I am using Arduino Uno, and this is a program which I did earlier to demonstrate this function. So I am going to upload this program. At that time you can see running LED, but I am going to upload. Uploading is under progress. Some issues happened related to my board. Now uploading is happening. Now the uploading is successful. It's a default program which I did earlier for demonstrating its functions. Now you can see running LED in the shift register module. So similarly you can see any kind of output. Further I will show you meticulously the different how we can use it for our functions. You can see a part of the program in red boundary. That's the core part of the program. Here we can see 4 shift out functions, and that shift out function will shift the data which we needed to the 4 ICs. 4 shift out functions stand for shifting the data to 4 integrated circuits, which we can see in the shift register module. Now I am going to make some amendments in the program to demonstrate how we can control each and every LEDs from the shift register module. So first of all I am commenting the 2 lines. That I am going to comment that for loop. For loop is not needed here for demonstrating its basic functionalities. And now I am showing the shifted function. That's a function which will shift the data from one IC to another IC. If you see the data sheet of shift registers, you can see its original usage. I am commenting these lines. Now I am going to there's a variable named data. I am going to give one value to this data. So the data which I am going to write here is in hexadecimal. So for starters it will be a bit confusing, but soon I will show you it in binary format, in binary code decimal format. Now I am passing a 0xff. 0xff means, and that data will be shifted 4 times. You can see at the bottom 4 shifted functions. So which means this data 0xff will be shifted 4 times, means every LEDs will turn on. Now I transmitted 0x00 like that, so every LED is turned off. Now I am transmitting a 0x01, which means only one LED is in the left side of each integrated circuit turned on. So to control, if you want to turn on only one LED like this, you just need to transfer 0x1. Now I shall show you it some more meticulously. So I am going to declare 4 variables: data 1, data 2, data 3 and data 4. And I am going to initialize those datas. You can get the link for this program as well as circuit from the links provided in my description. So this is our indigenous product, and hence you will not get this product from anywhere else. So you can purchase this product from the links provided in the description. I am going to initialize data 1, data 2, data 3 and data 4 with some values like this: data 2, data 3, data 4, and I am going to shift data 1, data 2, data 3 and data 4 to first, second, third and fourth ICs through that shifted function. Now you will not see any change, but I am going to change the values of 0, data 1, data 2 and data 3, data 4. At that time you will understand the effect of changing. I am going to change all the other values to 0 like this. So, and I am going to upload. Now you can see only all the LEDs except the last LED turned off. All the LEDs turned off except the last LEDs. So which means we can control a single LED in that manner. Now I am going to do it some more meticulously. It's a hexadecimal. You need to convert it into binary code decimal. That I will show you soon. Then only it will be obvious to some starters. Now I am transmitting 0x81. At that time you can see 2 extreme LEDs of the last IC will turn on. Now I transmitted 80, so the first LED turned off. Now I am transmitting 0x02, so first 2 LEDs will turn on. It's not obvious from the picture, from the LEDs, because of the brightness. Camera is not clear, so 2 LEDs are already in turned on position now. Now I converted entire data to 0x02, so first 2 LEDs of all the integrated circuits turned on. Now I am going to convert into 0xF2. F stands for in binary 1 1 1 1. So last 4 LEDs turned on, and the first 2 and last 4 LEDs turned on in the last IC, as you see. It's not obvious from the picture. Now I am going to, so far I transfer data in hexadecimal format. Further I am going to transfer it in binary coded decimal format. That will be some more obvious to starters. For that we should initialize it with a 0B, 4 zeros, and again we will have to add 4 zeros. So totally 8 zeros. 8 zeros means last one I put as 1, means 4 zeros, 7 zeros and 1 1, which means the first LED will turn on and the subsequent 7 LEDs will turn off. Now I put one in the start and one in the end, so you can see first and last LEDs turned on, remaining turned off. Similarly, which LED you want to turn, you please put 1 there, and which LED you want to turn off, you please put 0 there. It will be some more easier to you to comprehend. Now you can see the same effect in the third integrated circuit. I'm going to do it in the next one also. Yeah, I did it in the rest of the two chips, rest of the two data, and the entire LEDs turned in such a manner that first and last LEDs turned on, the rest turned off. Now I am going to make some amendments in data 1 by putting a 101010 combination. Now you can see alternate LEDs turning on and turning off. In the last step, it's not obvious. Actually, it is happening such a way that 101010. So because of this because of the intense brightness of the LED, it is not obvious. Anyway, it is working. So if you see it, if you watch it meticulously, you can comprehend that. So this is the basic usage of the shift register module. Means you will get 32 digital outputs from 3 digital input or output pins of Arduino, and using these 32 digital outputs you can control LEDs, you can make running LEDs, or you can control servos, you can make LED matrix, LED cube, anything you can make. That's the main purpose of this. Means a lot of situations will come where you need a lot of digital outputs than the digital outputs which we will get from the Arduino board. Now I am going to convert entire data to 0. You can see the code. So I am going to upload this program. You can see the entire LEDs will turn off. Entire LED is turned off. So you can purchase this module from the link provided in the description. Now you can see I am converting the last data to last bit to 1, and I uploaded. Now you see one LED, first LEDs of every the data which we enter and data and the what we see in the LEDs will be a bit capsized. That's only relies on the that you can easily reverse in the program itself, or you can, by capsizing the board, you can easily make it be fit for your function. So far we saw how we can get 32 digital outputs from 3 digital input or output pins of Arduino. So I think it will be obvious to most of you. So now we are going to see, if you want 64 digital outputs, what you can do. For that there is another way, that is cascading of shift register module. As you see, now I took one more shift register module, the same module, and I am going to place it in such a way that we can easily cascade both these modules to each other like this. So the advantage of this method is, by using only 3 digital input or output pins of Arduino, this is the diagram. By using only 3 digital input or output pins of Arduino, you can get 64 digital outputs, 64 digital outputs, which you can see for some more bigger functions. So no any other changes in the connection circuit to Arduino. We are doing the entire connection which we saw in the circuit diagram. we are going to connect between two ICs as we saw in the circuit diagram. We connected the second one. 5 connections should be there between these two modules. Similarly, you can cascade other boards also. So in each cascading you will get 32 extra outputs. That is the peculiarity of this board. That's the peculiarity of this module. So we gave the third connection. So the input signal connection is over. Next we are going to give the power. The board is designed in such a way that we can give the power also in very easy way. This is the power pin, and next is the ground. Next is the ground connection. That wire is a damaged one. I am going to put another one. So you can see the link for purchasing this module from the description. So the circuit is over, hardware is over by this time. Now we are going to do the same amendments which we did last time in the programs. Next is the software part, which we can see in the two sides of the screen. I am going to power the Arduino. Don't be confused in the current output. That's not a we don't need to concern about that. So this circuit is called the cascaded connection of shift register module. Now we are getting 64 digital outputs which we can address each one individually. That is the main peculiarity. So from 3 digital inputs, input or output pins of Arduino, we created 64 digital outputs. Don't be confused, we can use this only as digital outputs, 64 digital outputs, not as input. Here I am going to make the same amendments which I did earlier. I am going to declare 4 more datas like data 5, data 6, data 7 and data 8. So that's over. So now we can see totally there are 8 integrated circuit chips. So we need 8 shift outs, means each shift out is for each IC. You must understand that each shift out function will shift data to the each ICs. So there are 8 datas and there should be 8 shift out functions. I am going to replicate the shift out functions also. So each data 1, data 2, each will be shifted to each ICs respectively. So actually shifted function solely relies on the number of integrated circuit or shift register ICs. The name of the shift register IC is 74595. So entire data is now I'm going to convert the entire data to 0, as you can see, and I am going to shift all these data to the shift registers. Now you can see the result. Some issues related to my port. I forgot to choose my port as well as board. I transferred 0 and you can see entire LED is turned off. After that I transferred 1 to 7 zeros and 1 to 1 LED, so only one turned on. Now I transferred 1 to another one, again the other turned on. In this way you can see, you can control each and every LEDs of each and every LEDs in the 64 LEDs. That is the main peculiarity of this shift register module. So you can see I am controlling each and every one individually. You can address each and every LEDs of the 64 LEDs. So if you are taking some outputs from the shift register module to some LED cube or LED matrix, you can easily control each and every LEDs for making your own favorite patterns. In the starting you already saw one running LED which I already created. I'm putting a space to bunch the data transferring to each shift register modules as different. So first 4 will be to the first IC and the second bunch of 4 will be to the second IC, and I am converting everything to 0. No, I am putting the first bit as 1 everywhere. So you can see the last LEDs will turn on. That's fine. Now I am setting the bit of 5th bit in each data, and I am uploading. Yeah, it's not obvious. Actually what's happening is in each IC 4th as well as 8th LEDs in turned on condition now. 4th as well as 8th. Now I am unsetting the first one. Now you can see only the 4th LED in turned on condition. Now I am going to turn off, unset all the bits. So all the LED is turned off. So we controlled each and every bits in this shift register, in the outputs of this shift register module independently. and I set as 1. I'm doing this again and again for demonstrating you. We can set it in any way. So in the first IC 1 I set, in the second IC 2 I set, in the third one I set 3 bits, in the fourth one I'm going to set 4, and in the fifth one I'm going to set 5 bits. Just to convey you that every addressing or every mode of controlling is possible. So you can see, and in the 8th one I'm going to set the all the 8 LEDs. You will not feel that difference because of this intense brightness, but actually it is in the pattern which I programmed.